What if the next massive scientific breakthrough isn't discovered by a human at all, but by an AI? Well, today, we're going to look at a brand new framework called ASI-EVOLVE. And it's built on this pretty wild idea. What if you could create an AI that can actually speed up its own evolution? Let's dive in.
I mean, think about it. For decades, the entire field of AI research has been pushed forward by us, by humans. But what if that's all about to change? This research really kicks off with a question that honestly has always felt like something straight out of science fiction. Can an AI actually accelerate its own development? All right, so here's how we're going to break this down. First, we'll talk about the big problem holding AI back, the human bottleneck. Then we'll introduce the AI built to fix it and unpack its cognition loop. After that, we'll get to the results, which are seriously impressive, and wrap up by looking at what this all means for the future of research. Okay, so first up, the human bottleneck. Why is AI research limited by us? Let's get into it. Just think about how AI progress works right now. Yeah, it relies on human brilliance, but it's also stuck with our human limitations. I mean, the space of all possible ideas is just massive, way too big for us to explore all at once. Every experiment, every workflow takes so much manual effort. A lot of the time, breakthroughs depend on one person's gut feeling or their specific experience. And that kind of knowledge, it's really hard to pass on or scale up. Basically, we've become the bottleneck. We are literally the speed limit for our own creations.
So that's the problem, and this is the proposed solution, an AI designed to improve AI. Let's meet ASI-EVOLVE.
So what exactly is ASI-EVOLVE? At its heart, it's what's called an agentic framework. Now, don't let the jargon throw you. It just means you should think of it less like a simple tool that just waits for your command and more like, well, like an autonomous scientist in a box. You don't give it step-by-step instructions, you just give it a goal. And its goal is maybe one of the most ambitious goals out there right now. Figure out how to make yourself better. And this is really what makes it so different from anything else. This system isn't just about tweaking one tiny little variable. No, it's the very first system built to tackle all three core pillars of AI development at the same time. We're talking about the data that it's trained on, the architectures, the actual blueprint of the AI, and the algorithms that make it smart. It's basically a full-stack AI researcher.
Okay, so how on earth does a machine learn to think like a scientist? Well, the secret sauce is something the researchers call the cognition loop.
This loop? This is the engine. It's basically the scientific method, but put on hyperdrive, automated and massively accelerated. It all starts when it learns, soaking up decades of human research. From there, it designs a totally new solution. Then it runs the experiment. And then comes the magic part. It analyzes those messy, complex results to pull out real, actionable insights. And those insights, they get plugged right back into the start of the next cycle. It's a nonstop, self-improving feedback loop.
And this really puts it all into perspective, right? You look at human research, and it's slow, it's manual, it's often based on a hunch. Our scale is just limited. But then you look at this AI cognition loop. It's incredibly fast, it's completely automated, and it's driven by pure data. And the scale? It can explore a space of possibilities that is just mind-bogglingly huge.
Now, this whole loop is powered by two really crucial components. First, there's the cognition base. Think of this as its library. It's injected with tons of human research papers and knowledge. So the AI isn't just starting from scratch. It's literally standing on the shoulders of scientific giants. Then, once an experiment is done, this super clever module called the dedicated analyzer kicks in. It takes all that messy raw data and boils it down into structured, reusable insights. That pure wisdom is what fuels the entire next cycle.
So the theory sounds great, right? But does it actually work? Okay, let's get to the results, because this is where things get really wild. First up, they gave it a really tough job. Discover brand new model architectures. We're talking the basic blueprint of an AI's brain.
And it didn't just find one or two good ones. It discovered 105. 105 brand new, state-of-the-art architectures, every single one of them better than the top human design models. Just let that sink in for a second. Its single best discovery? It wasn't just a little better. It beat the previous best model by a margin 3 times bigger than any recent breakthrough made by humans. That's insane.
All right, next challenge, data. They basically asked it, hey, can you figure out how to create a better data set to train other AIs? And yeah, it could.
It automatically came up with new ways to clean and curate data, creating a dataset so good that it boosted another model's performance on a major knowledge benchmark by over 18 points, an 18.64-point gain. That's a huge leap, and it was achieved not by making the AI smarter, but just by giving it better information to learn from. It's like giving a genius a better library.
And finally, they gave it the ultimate test, the big one. Could it actually invent entirely new ways for an AI to learn? Could it create a brand new learning algorithm from scratch?
And once again, it absolutely nailed it. The system came up with novel reinforcement learning algorithms, all on its own. When they tested it on a really tough math reasoning problem, its new methods blew the old baseline away by 12.5 points. Seriously, think about what that means. The AI wasn't just solving problems anymore, it was inventing entirely new ways to think.
Okay, so this all leads to a really crucial point. This isn't just about making research faster. This is something else entirely.
Look, this is probably the most important thing to understand. Most AI is built to get better at finding solutions. This system is different. It's designed to get better at thinking. It's evolving its own cognition. It's not just finding better answers, it's learning how to ask better questions. It is actively, constantly improving its own ability to reason.
And to prove this wasn't some kind of fluke, just a one-trick pony for AI problems, the researchers pointed it at a completely different field, biomedicine. They asked it to design a better model for predicting how drugs will interact with targets in the body. And guess what? It worked. It independently discovered a new architecture that gave a 6.94-point boost in performance. This proves that this isn't just an AI for AI thing. This could be a new paradigm for science, period.
So, what does this all mean for the future? Well, it looks like we're heading towards a whole new way of doing research.
And that brings us to this incredible new vision for what research could become, which I think is summed up perfectly by this quote from the paper. See, the goal here isn't to replace scientists, it's to free them up. It's about letting the AI do the heavy lifting, all that endless, tedious work of finding solutions, so that human creativity can focus on what we do best, defining the next great problem that needs to be solved.
So in the end, we're kind of back where we started. This was never just about building a smarter tool. It's about building a tool that can build smarter tools. It's an engine of discovery that can actually upgrade itself. It's like a flywheel for intelligence that just spins faster and faster with every single rotation. And that leaves us with one last profound and maybe even a little unsettling question to think about. What actually happens when the engine of discovery finally learns how to redesign itself?